In this video, you will learn to determine the number of roots by looking at the degree of an equation, as well as use that concept and the conjugate root theorem to determine the equation when given the roots. So let's walk through these different theorems. So the first one is considering the degree of an equation and the number of roots. And this theorem says that the degree of an equation will equal the number of roots. So here's a table to illustrate that. Look at the equations in this far left column. Okay, the first equation, the degree is 1. The exponent is a 1 with the x, and there's only one root, one answer. Whereas the second equation is a quadratic equation with an exponent of 2. The degree is 2, and so we have two roots, and we see them listed here as 3 plus I and 3 minus I. So the degree of 2 means we have two roots. If we have a third power in the equation, a third degree equation, there's going to be 3 roots. Fourth degree, fourth roots, fifth degree, fifth roots, and etc. So that's the first theorem. The next theorem is called the conjugate root theorem. This says that if a polynomial equation has a plus bi as a root, then its conjugate, a minus bi, is also a root. Now keep in mind a and b are just any numbers. So for example, if we have 3, let's say 3 minus 4i is a root, then 3 plus 4i would also be a root. And remember, I is the imaginary number. All right, so if 1 is a root, the conjugate would also be a root. And here in the next example, we have 7i. If 7i is a root, think of that as maybe 0 plus 7i, where the a value would be 0. The conjugate would be 0 minus 7i, or simply negative 7i. So if positive 7i is a root, then negative 7i would also be a root. And this kind of has to do with the quadratic formula. All right, remember the quadratic formula. You have x equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So if you go through all that process with solving, you have one with a plus sign, so the plus the square root, and then a minus the square root. So that's where this idea comes from, is because we're going to have 1 plus, 1 minus with that square root. So that would be the conjugates. Now we can use these two different theorems to determine an equation if you're given one or more roots. So for example, here if we are told to write a quadratic equation with roots of 3 and negative 4, we can use this information to write an equation. Now this one we've actually learned in a previous lesson, a shortcut to write this, but I want to refresh your memory with the longer method, because in the next examples you're going to need to know the longer method to be able to determine the equation. It's going to get more complicated. All right. So for this one, yes, there's a shortcut, but we're going to go through the longer method as well. Now remember, a quadratic equation means it's going to be something squared, right? Something squared. And to think through this, we need to kind of think in reverse, where we have x and then minus whatever we have here. So x minus 3. And then here we have x minus a negative 4, which makes it a plus 4, right? Because if this is our equation, right, this would give us roots of positive 3 and negative 4 when you solve it. So this is your setup. Whenever you do these types of equations, you're trying to determine an equation, we take the roots and do x minus whatever root we're given. So x minus 3, x minus negative 4 makes it a plus 4. And then for this one, we can just distribute. We get x squared, and then outer would be 4x, and then inner would be negative 3x, and then last would be negative 12. So we have x squared plus 4x minus 3x minus 12 equals 0. These can combine, you get x squared plus x minus 12 equals 0. So this here is a quadratic equation that has roots of 3 and negative 4. Now, using that concept, we're going to increase the difficulty, where we still are trying to write a quadratic equation, but now we have imaginary numbers. We have 5 plus I as one of our roots. And again, you could use the shortcut method we've learned in a previous lesson, but again, I want to show you the longer way because, like I said, in the next example, we're going to need to know how to do this longer method. And so we're building in complexity. All right, so here, quadratic equation means we have something squared, right? Which means we also have a degree of 2, which means we have 2 different roots, right? The degree indicates the number of roots we have. So this is one root, which means we must have one other root. While using the conjugate root theorem, if 5 plus I is a root, then the conjugate 5 minus I must also be a root. Now your setup for your equation is going to look kind of weird because remember we said when we set this up we're going to have x minus your root. So x minus, that's going to be a 5 plus I, that's going to go right there. All right, and then same thing over here, x minus the root, so x minus 5 minus I, right there. So it looks weird because we have 3 terms in here. And we can simplify this a little further because the negative goes to both terms, negative 5 and minus I, and it goes to both terms here, negative 5 and negative I makes a plus I. So x minus 5 and then plus I. And that is set equal to 0. We're going to skip to the typed up notes. So we see right here exactly what we just had written. And to finish this off, we just need to distribute. We need to multiply these two polynomials. Now remember, when you multiply, you're basically distributing multiple times. So you begin with the x, you distribute that to the x, the negative 5, and the I. That's going to give you x squared. It's going to be negative 5x, and then plus ix. We do the same thing again with this negative 5. Negative 5 times x times negative 5 and times I. That gives you negative 5x. Negative 5 times negative 5 is plus 25. So plus 25. And negative 5 times I gives you negative 5i. And then one more time, do that with the negative I. We distribute that to each term. Negative I times x is negative ix. Negative I times negative 5 is a positive 5i. Negative I times positive I is going to be negative I squared. And all that is equal to 0. All right, so now this looks kind of like a mess, but a lot of this would cancel out. So notice the ix with the negative ix, those cancel. Negative 5i plus 5i, those cancel. So we have x squared in the front. Negative 5x minus 5x can combine to get negative 10x. Then we have plus 25. And then right here, this negative I squared. Remember, I squared is negative 1. Negative 1, right? Because I is the square root of negative 1. I squared is negative 1. So what we have is minus a negative 1, which is actually a plus 1. So what we have is 25 plus 1, which would be 26. And all that is equal to 0. So notice everything is much simpler now, and this is our equation. So x squared minus 10x plus 26 equals 0 is our equation that has 5 plus I as one of the roots. Let's take a look at one more example, where here we are told to find a cubic equation that has 4 and 2 minus I as roots. All right, so this one is a little more convoluted, still the same kind of process here. But cubic implies that it's going to be something to the third power, which means we have 3 roots. Here we have 2 listed. The one we're missing, so the one we're missing is going to be the conjugate of 2 minus I, which would be 2 plus I. That's from the conjugate root theorem. So we have 3 roots. We have 4, 2 minus I, and 2 plus I. So we can use those roots to set up our equation. All right, so to do that, we do x minus each of the roots. So we have x minus 4, x minus the 2 minus I, and we have x minus the 2 plus I. Alright, so that will be our equation, which from here we're going to have to simplify and multiply things out. So we see that typed up right here. And remember, the minus in the front goes to both terms, so we have a negative 2 and a plus I, so x minus 2 plus I. And then here we have negative 2 and then minus I, so x minus 2 minus I. And then x minus 4 in the front. And we see that typed up right here. Now from this point, we're going to need to multiply all of this together. So it's going to be kind of messy here. It's going to take some time, but we just do it one step at a time. So let's focus on this over here because this is going to have a lot of things cancel out for us. So when we multiply, we do the same thing we did in the last problem. The x goes to both terms, or all three terms. We have x times x to get x squared. X times negative 2 is negative 2x. And x times negative I is negative ix. And then same thing with this negative 2. Distribute that to all three terms. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. Negative 2 times negative I is a positive 2i. And then same thing with the I right here. We distribute to all three terms. I times x is ix. I times negative 2 is negative 2i. I times negative I is negative I squared. So we've distributed. Let's combine like terms before we do anything else. So we have negative x, positive x, or negative ix, positive ix. Those would cancel out. We have a plus 2i, minus 2i. Those would cancel out. So we're left with an x squared in the front. We have negative 2x minus 2x. Those combine to get negative 4x. And then remember over here, this negative I squared. I is the square root of negative 1. So I squared would be just negative 1. So minus negative 1, which becomes a plus 1. So we have 4 plus 1, which gives us 5. So we have a plus 5 there. That's equal to 0. And don't forget, we still have the x minus 4 in the front. So we've jumped over to typed up notes, which this is everything we just had written out. And we're not quite done yet because we still need to multiply the x minus 4 to everything. So when you do that, we distribute the x to all three terms to get x cubed, negative 4x squared, and plus 5x. Then same thing with negative 4. Negative 4 times x squared. Negative 4 times negative 4x would be plus 16x. And negative 4 times 5 would be negative 20. And then all of that is set equal to 0. So from here we can just combine like terms. We have an x cubed by itself. Negative 4x squared minus 4x squared would be negative 8x squared. Plus 5x plus 16x, that gives you a 21x. And the minus 20 by itself. So our final equation would be right here. X cubed minus 8x squared plus 21x minus 20 equals 0. So this equation has roots of 4, 2 minus I, and 2 plus I. So it's kind of a long process, but if you are careful, this would be your correct answer. And that concludes our lesson for today. We will see you next time.